This is a world where the normal rules of physics don't work.
Oh wow, I'm inside now.
Where time and place are no longer certain. A world so weird that it hardly bears any relation to our own. But amazingly, this strange world exists inside every single atom and molecule.
I mean, the symmetry of this molecule is amazing. You know, there's 60 carbon atoms there.
It's chemistry, dominated not by test tubes and Bunsen burners, but by lasers, virtual reality, and quantum theory.
I work with quantum theory, okay? So it's a mathematical theory that used to try to understand what goes on at the molecular level. Now, what never ceases to impress me is the fact that we can use this precise theory that relates to extremely small scale molecules. We can use this theory to predict, without any ambiguity, the structure of molecules in light years away in interstellar space. Okay? And it's the most precise method to predict experiment in history.
Keith is back in Britain after 2 years in Texas, working with some of the world's leading experts in theoretical chemistry. It's a remarkable achievement, especially for someone who left school without a single science qualification to their name.
I left school at 16. I had an O-level in economics and music, and I had a CSE in English, Welsh, and I think I had maths CSE. Couldn't wait to get out. My ambition, my desire was to join the army, and I didn't join the army immediately after leaving school, but I joined a few years after, and I wanted to join the best unit in the British Army. I wanted to be a paratrooper.
Paratrooper training is notoriously physical. It's known as one of the toughest military selection processes in the world. Incredibly, out of the 45 people who enrolled, Keith was one of only 5 who made it into the brigade.
There's no grand parade or anything. You just sit in the lecture theatre in the army, and the officer calls out various names. Jones, he stands up. Fail. Smith, pass. And that's all you do. Came to me. Hughes, stand up. Pass. You just don't. And you just go, yes, that's it, my maroon beret. And as I said, there's no big parade. You go down to the stores and you're issued, there's your red beret. And that's it. But to me, it was priceless. It was winning the lottery.
He spent 4 years in the army, but a rainy day on Salisbury Plain made him reconsider his future.
I was sitting in a shell hole with a friend of mine, and we were talking about what we're going to do when we leave the army. I think most soldiers have this discussion. And my friend said, well, I fancy being a physiotherapist. And I said, don't you need qualifications for that? And he said, yeah, you need A-levels and you need to go through college, but you can go to night school or you can do these access courses, these access to higher technology courses. I said, well, yeah, that sounds good. Science though, I just can't handle science. And he said, well, you might find it a bit better now at science than you were at school. You'll be surprised at how good you might be. So I had this phobia about science, so I was curious about it, but didn't really, deep down, I didn't think I'd actually go through with it. So the seeds of my future were actually sown on that miserable day on Salisbury Plain.
Last year, Keith was awarded the prestigious Ramsay Memorial Fellowship, given to chemists with the potential to become world leaders in their field. His work looks into chemical reactions and the way energy disperses when molecules break up, something that could have practical application in the real world.
The aim is to start off maybe with molecule A, molecule B. These react to form molecule C. Quite often the amount of molecule C that we get is only maybe about 50% from the initial starting point. What we want is 100% yield. This is definitely of interest to pharmaceutical companies, any company. Okay, we don't want waste.
In the future, Keith believes chemistry won't be done like this. Instead of crudely heating chemical mixtures, he wants to apply the latest theories to create tools that are tuned precisely to how molecules behave in the microscopic quantum world. What's
required to get this 100% yield? We generally work, because quantum theory is very precise, we need very precise equipment, and the equipment that we I can envisage, well, that we do need is lasers, okay? Lasers work over a very narrow energy range, and they can deliver this energy over a very short timescales. Talking femtoseconds here, well, that's 0 point, and you've got 14 zeros followed by a 1. That's 1 femtoseconds, okay? So we're delivering energy over just a few femtoseconds, and it's just one quick zap, and hopefully what happens is we excite this strong bond up here, and we leave all the other bonds cold, okay?
Since he was a child, Keith's home has been in North Wales, and when his fellowship came through, he chose to take it at the University of Bangor so that he could keep his family in the area. He's proud of his heritage, and it was important to him that his son could go to the same schools as he went to and play on the same beaches. And when he decided to leave the army and take an access course into higher education, his first choice was the local college in Bangor, where he was surprised to find he was consistently top of the class in science.
At times I felt as if my mind had been taken over by another scientist, you know. I can't do science, what's happening here? Somebody's taken my mind over. It's not that I couldn't do it, it's just that I was another, different period of my life. I wanted to do this. Initially I think I had to do this, but then I want to do this. Then I want to do this became I love this. Then I love this became this is my passion. This is what I want to do for the rest of my life.
Keith eventually enrolled on a chemistry degree at Bangor, picking up awards for the best chemistry student at the end of his second year and best overall student in the university when he graduated. He went on to do a PhD under his head of department, John MacDonald, and won a prize for that too.
The most surprising thing about Keith, I think, is that none of this inherent ability in mathematics or in physical science appears to have been evident when he was at school. There seems to have been absolutely no evidence of it, certainly nothing that anybody picked up on. And I think the most surprising thing is that once he came out of the army and decided to get an education, that he found his way into this area where all this ability suddenly made itself apparent to all around him and to himself.
Keith is now passing on his enthusiasm to a new generation of students, holding tutorials and becoming a lecturer for the first time. He's also thinking about writing his first book.
Keith has picked up the determination and the commitment that's needed to succeed on the career path that he's now on while he was in the army. And if that's true, then maybe we should send most of them through the parachute regiment for a bit of training.
One of the problems with Keith's work is that his mathematical models are so difficult to visualise. But today he's in Hull, visiting one of the UK's most advanced computer visualisation units. They have a new toy, and he's hoping that it will offer him a unique insight into his calculations.
So welcome to the Hive. And welcome to our visualisation auditorium.
It's a room set up to allow scientists to view their data in a completely immersive 3D environment.
Straight in. If you'd like to take a pair of shutter glasses.
Okay.
Using the gamepad.
2 computer images are generated, each drawn from a slightly different viewpoint, and these are rear projected onto the massive screen. The shutter glasses allow the right eye to see one image and the left eye the other, creating an incredibly strong illusion of real depth.
I see the potential applications for this, in medicine, not to mention sort of my field of research. I mean, I'm almost grabbing this thing now, the handle.
We'll be able to use the work wall in conjunction with our 12-camera motion tracking system.
This is just part of a whole unit set up to develop cutting-edge virtual technologies, and scientists from a wide range of disciplines are being encouraged to use these machines and perhaps discover new ways of working. For example, this pen allows the user to feel an object, which could in reality be on the other side of the world. And this program allows you to visualise how radiation enters a human body and could be used by doctors to better target cancers. Back in the virtual auditorium, Keith found something to get really excited about. It's some data from a geography researcher who's been looking at the flow of silt on riverbeds.
Yeah, this is excellent.
But this type of visualisation is just what Keith needs to bring his data on chemical reactions to life.
Yeah, this beautiful isosurface here. I can look around the thing. I can look in detail at these vectors. If I rotate it again, I look at these things called wave packets, or a wave function in general. Now in quantum mechanics, a wave function tells you everything that can be known about the whole molecular system or quantum system. I can look inside. They got them inside as well. This is amazing. This is the kind of thing that would benefit my research, definitely. Now, a lot of my work involves a lot of thinking, dealing with theories, mathematical equations, and when you're doing this for 12 hours a day, you quite often come to a mental block. And I've just go up the mountain, just go for a run, and all of a sudden something pings. It's just inspirational. Maybe that's why scientists have their conferences in mountainous regions.
Keith has lived in the same village all his life, and his best friends now are the same friends he had at school. He's taken a very different path to the one he set out on, but he's refused to let it affect the way he lives his life. He's in the country he loves, surrounded by the language he loves, and working in an area of science he's completely passionate about.
If you ask the average worker in Britain what would they do if they won the lottery, ask them if their lives would change, most of them, 99% of them would say, yes, I'd quit my job. 1% of them would say, no, I'd carry on as normal. If you ask me if I won the lottery, would it change my life? Yes, without a doubt. It would mean I could focus more on my attention to my work. I could buy the best equipment. I could travel and meet with people in America. I wouldn't have to worry about applying for funding or whatever. So that to me sort of summarises everything about our love for science.
Bright young people sometimes burst on the scene like a supernova, last for a relatively short period of time and fade away again for any one of lots of reasons. In Keith's case, I think he'll stay the course. I think because of his curious start, he's got sheer determination built into him, and I don't think, having struggled to get here, that he's going to let it go.
Everybody has a hidden talent, and it's never too late to discover that. Even if you're not going to be the best in your field, if you always give 100%, you can beat the rest, you can beat most other people. You can be in the top 5%. If you've got a talent there, you can be in the top 1%, or you can be the best. You just need to try it, take that jump.